Hi, this is a presentation I'm doing about the video I did on Rhetoric. I broke the globe and trying to explain to you why it only validates a flat earth and it cannot work possibly on a globe. Well, let's get to it. We'll start with the basic geometry. This is actually Euclidean geometry, which is actually used for surveying. All lines are straight. All triangles do not work on a curved surface. Parallel lines do not intersect or cross. This is the fifth postulate. Surveying is based upon planar geometry. Geodesics require you to throw the fifth postulate out. Curved surfaces invalidate an angle. You cannot acquire a straight angle from a curved surface. I think that's very straightforward, and the reasons are very clear. We'll show you. Here we go to simple definitions. Level, if you can't read or understand, I don't know how we're going to get this to you, because you have to understand when it comes to level, it is horizontal, it's flat, and it's planar geometry. You do not have the curved straight lines, you do not have curved flat, you do not have curved horizontal. So I'm just putting all the definitions here so you can just get a very basic understanding. That's something you should have learned in school. Again, horizontal is a plane of the horizon to right angles to the vertical. Right angles can only happen with straight lines. It can only be flat, same height, level. Still we go on, flat. I think that's very self-explanatory. It's amazing how level, horizontal, flat, and planar geometry all have the same thing in common. None of them curve. They're all intertwined to each other. Another one, plane, same thing, just showing so you can see it's a flat surface, which is very explanatory. It's level and flat, not curved, as people like to say. And then just plain geometry. It's Euclidean geometry, and it requires a flat surface or deck to work. In mathematics, a plane is a flat two-dimensional surface that extends infinitely far. I think you'll get that clear. Okay, why do the points meet up on a flat earth? Yeah, I'm showing the graph, and what's based on the graph. Understand that on the flat earth, the observers are not in a straight line, but have a 3D arced path towards the observation. This is what I said in my video, that the graph does not line up when taken into account the viewing is in a different observers around the stage. This is what I was trying to explain with the video, which people like Where's Wally just try to ignore, so people think I'm lying. Doesn't Reds realize that that viewpoint towards Polaris on a flat earth, which it is, would be viewed on a curved path, almost like an auditorium or stage where you sit around the stage and look at the same point? So there you go, that's what meets up. It's not an actual straight line like the graph reads, plotted, very dishonest. Okay, why does the globe not work with triangulation? This is based on Red's graph of his one that he says had no contradiction. I think you can see the problem. Remember that the geometry facts that we had? The first issue is that the surface is not level, it's curved. How are you going to get an angle? And as you see, the further away you go, you are from the observation. So you're actually looking away from the observation the further around the curve you go. And yeah, I'm just trying to depict why it would be. Okay, it's a straight line according to Reds, but according to the model reality, it would be a curved line on the surface. So it's not actually straight, the deck is curved. So you're not going to be able to actually get an angle to Polaris if the surface is curved. Yeah, I'm showing the same thing again, just showing it's a straight line. You get obviously the point of the argument. You're standing on a curved surface. so it's not actually straight. Straight lines cannot curve. So you've already thrown away Euclidean geometry, which invalidates your angles. Yeah, I'm showing you what's going to happen the further you go away. You can really see a problem here. The further away from observation, the more the deck will change the angle. Thus it is impossible to be able to get your angle. You see, this is what I mean. The further you go away, the angle is going to become greater than it is from the deck, and thus you're actually looking from underneath the deck. So how are you going to get your triangulation angle that you need? This is why Rhetoric's orthographic graph was such a major fail. That's why he couldn't get the angles to align up and to actually look towards Polaris. As he said, there wasn't a contradiction. I think he knew there was a huge contradiction. Okay, let's compare the triangulation methods. The red chip is for the flat earth and the green chip is for the globe. I think you can already see the problem here. You can see the green chip's plumb is not going to show the same at different distances. It's going to have a new plumb. So it's just going to have a different vertical towards Polaris. So it's always going to change the angle. So the further away you get, the more the angle is going to change because of your surface you're standing on. You're never going to get an accurate observation reading.